While a low-pass filter can be useful for filtering out high frequencies from a signal, we might also need to filter out the low frequencies. For this purpose, we have special kind of circuits called a high-pass filter. This is Abhinav from learnelectronicsindia.com, and let's make an active high-pass filter using OpAmps. A traditional high-pass filter consists of a capacitor and a resistor connected like this. The input signal is given from the left-hand side, and the right-hand side gives the output. The capacitor is in series with the output signal. Hence, capacitive resistance is given by this. From the formula, we can see that as the frequency increases, the capacitive resistance decreases. At high frequency, the capacitive resistance is nearly zero. Hence, at high frequencies, the capacitor acts as a short circuit, while at low frequency, the capacitor acts as an open circuit and Vout is nearly zero. By using this principle, we can make all the high frequencies pass through the circuit and obstruct all the low frequency. But such passive RC filters causes loading issues when connected to the circuit. To tackle this issue, we connect a voltage buffer at the output, so that we have a high input impedance and low output impedance, thus eliminating the loading effect. To make a voltage buffer, first we will take a LM741 IC with plus 12 and minus 12 volt as the supply voltages and short the inverting input and the output, and connect the output of the passive filter to the non-inverting input. The cutoff frequency for a high-pass filter is given by this formula. Let us set the value of resistance as 1 kilo ohms and the cutoff frequency as 10 kHz. Hence, by this formula, the value of capacitance is 0.015 microfarads. To see the frequency versus amplitude graph, we need to click on Simulate and select Analysis and Simulation. Then we need to select AC Sweep and set the start frequency as 1 Hz, stop frequency as 10 MHz, sweep type as decade, number of points per decade as 10, and vertical scale as logarithmic. In the output section, we will select the output of the OpAmp. In this case, it's V3, and press Run to see the graph. From the graph, we can observe that the filter allows all the frequencies about 10 kHz to pass through it and blocks all the lower frequencies. By using such circuit, we can filter out low frequency noise from our signal without causing any loading issues. You can find detailed explanation along with the multisim file at our website link in the description. This is Abhinav from learnelectronicsindia.com, and thanks for watching.